Hello everyone, I am Dipran Bhandari and in this presentation I will define STEM and STEM education, explain their relationship and critically discuss the possibilities and limitations of implementing STEM education programs. STEM refers to the integration of science, technology, engineering and mathematics to solve real-world problems. STEM education, however, is the approach used to teach these disciplines in an interdisciplinary and applied way, focusing on developing skills such as critical thinking, problem solving, and innovation. According to Jamali et al. In 2022, STEM education improves the quality of education by promoting interdisciplinary learning and preparing students for future workforce demands. This suggests that STEM is not only about knowledge, but also about how that knowledge is applied in real world contexts. Talking about examples, in STEM education, it is implemented through integrated curricula, project-based learning, and digital tools. From a research perspective, Ogunkola and Knight in 2018 found that structured visual and technical activities significantly improve students' mental rotation ability, which is essential for spatial thinking in STEM learning. In industry, STEM knowledge is applied in fields such as engineering, artificial intelligence, and data analytics to solve complex real-world problems. Now, for the historical development, the development of STEM can be understood through four industrial revolutions. The first introduced mechanization, the second brought electricity and mass production, the third introduced digital technologies, and the fourth focuses on artificial intelligence and automation. This progression shows that the STEM has evolved alongside technological advancements and has become essential in modern society. Now, for the types of thinking, STEM education involves multiple types of thinking, including critical thinking, computational thinking, design thinking, and spatial thinking. According to Ogunkola and Knight in 2018, students who engaged in visual and technical activities showed significant improvement in mental rotation ability compared to traditional learning environments. This indicates that interactive learning approaches can enhance cognitive development in STEM. In addition, Aslin et al. In 2018 argues that knowledge formation occurs through both physical and virtual environments, where face-to-face interaction supports tactic knowledge and digital platforms enhance accessibility and collaboration. This highlights the importance of blended learning in STEM education. Now, for the possibilities, STEM education offers significant possibilities. According to Jamali et al. 2022, STEM education enhances educational quality by promoting interdisciplinary learning, creativity, and problem-solving skills. Similarly, Sandal et al. 2018 identifies subject integration, project-based learning, and collaboration as essential components of effective STEM implementation. Additionally, digital and interactive tools for the strengthen learning. For example, during my internship, I developed HTML-based learning lessons incorporating interactive games to help children understand concepts more effectively. This reflects the finding of Ogunkola and Knight in 2018, who highlight that visual and interactive activities enhance spatial reasoning and cognitive skills. However, there are some limitations to it as well. Housepast 2011 argues that STEM lacks a clear and consistent curriculum structure, making implementation difficult in schools. He also explains that integrating multiple disciplines require strong coordination, which is challenging in traditional subject-based systems. In addition, Sandal et al. Emphasized that successful implementation requires time, support, and teacher training. In conclusion, STEM and STEM education are closely connected but distinct concepts. While STEM represents the discipline, STEM education is the approach used to integrate and apply them. As highlighted by Chamali et al. 2022, STEM education has strong potential to improve the quality of education. However, as discussed by Hotspurs 2011 and Sandal et al. 2018, successful implementation depends on curriculum design, teacher training, and institutional support. Therefore, while STEM education offers significant opportunities, addressing its limitation is essential to fulfill realize its potential. Thank you.